Hello guys, welcome to the Laptex. My name is Nasser and today we have HP G3 840 laptop, and I have received it with the battery also, as it was written that the battery is not charging, but I have received it in the dead condition. I don't know how it was dead. Might be he was trying to repair and it got dead. So there is a on off light, on off switch with the light. I'm just pressing it, no indication on the load. So how can you repair motherboard if you don't have a schematic? So let me tell you one thing, that first of all you need to understand the basic thing, like how 19 volt enters into the motherboard, like with the help of P channel MOSFET or with the help of N channel MOSFET, or sometime with the diode plus N channel, diode plus P channel MOSFET. Then it reaches to the sensing register and then it go across the motherboard. One thing, the motherboard when it receive 19 volt on the sensing register, then your 3.3 and 5 volt regulator start working. First of all LDO will be generated, then 3.3 and 5 volt S5 voltage will be generated on the coil. So this is the basic logic of the dead motherboard. Any laptop you receive, whether there is a schematic or no, doesn't matter, because look, there are some logics. Let me move it a little bit so that I could show you. Like here you don't have a schematic of this model, and here is a 3.3 and 5 volt regulator. You might have seen many time in the G3 model, G3, G4, G5, G6 model. This type of regulator are used. There are the name, like let me confirm it, ALVG or something like that, APAG. This type of nomenclature you will find every time in your motherboard. Let me zoom it. Now you can see here the name of the 5 volt regulator, APAG. So if you don't have a schematic, then how can you determine that what voltage should be where, and how can you determine it? For example, I have checked it, I have found it. This is the 1 number pin, this is the win, always in any type of however the same design of IC comes with 1.1 volt, or also it comes for the RAM IC 1.35 volt. The LDO are fixed in this type of regulator. So win is on the 1 number pin, 5 is enable pin, 6 is LDO. The same power good is around 1 2 3 4 5 6 7 8 9 or 10 number is power good. It is mentioned here. Okay, so this is the regulator. So where is the 1 number, and enable is the 5 number. PL hash, I don't know what is this. This is the 10 number. Sorry, I was telling you that LDO is there. This is the 10 number pin is your LDO 3.3 volt. The same way you can use the same schematic you can use. The IC name is NB681. So might be different IC has the different voltages, like NB680, that would be 5 volt regulator here instead of 3.3, because LDO is fixed. So instead of 3.3 volt you will get 5 volt there. So let's find out why your laptop is not turning on. So let me begin it from here. If you don't have any idea of motherboard, you just start with the IC searching, like what is the IC name. You just search the APW, whatever is written on the IC, and you will find equivalent name. RT usually make this types of IC. NB681 you will find 3.3 volt. So now I am going to check pin number 1 of any of this regulator. Since I have found it, this is the 3.3 volt regulator, and how can you this is the motto to make this video, that how can you repair those motherboard which has no schematic available. Nowadays HP G series 3, HP X360 series has no schematic. So you have to be ready yourself to repair this type of motherboard. I am going to check VIN on the pin number 1. So Win is 4 volt instead of 20 volt, because as you can see here that I am injecting here 20 volt on the motherboard, but I am getting here merely 4 volt. Now you have to know that who allows voltage to enter in the motherboard. That is the charging IC. So BQ is the charging IC famous for Win section, the DC in section, and as well as it is also famous in the mobile technology, because mobile PCB has mobile always use the BQ IC for the charging section, also as well as the laptop, but both are the different name and pins configurations, but the process are very same. So here is the 24780S charging IC, and you need to understand that how does it work. So what I am going to do, you have to recall, either you can download the data sheet of this IC. Let me show you. I just type here BQ. This is the IC, and I have the PDF. Okay, I have the PDF here, and apart from this PDF, if you could recall that you have somewhere seen where the schematic is available, like as I could recall, that is NM, that is the Lenovo motherboard, NM hyphen A7 and A751. Okay, idea pad. Now let me write here 80. Okay, I have seen here in this model, I have the pin configuration would be very same, might be a little bit difference of the helping components, the area as it is associated. These types of things could be little bit different, but the pin configuration would be always same. Like 28 number pin would be Win, VCC, DC in. Here you need to get usually directly, sometime you will without diode you will get voltage, but across the 10 ohm resistor, because the current is something which we do not check. What we check as per Ohm's law, we check voltage, we check resistor value, and we know that the current is okay or not. If the V is all right, if the R is all right, then 100% your the current is going across this resistor is 100% all right. Now usually you will see the DC in area which will go on the charging IC will go across a very minimum amount of resistor, like 10 ohm or 20 ohm in every motherboard. So we expect that we will get this also here. Okay, and the second thing, AC detect, that will determine that the voltage, the wattage through this ID, whatever I am using here, it will determine that it is right or not. Like, how can we determine that the 20 volt is 20 volt, because we can see here but it has no eyes. So it will sense across a divider, and it will reach to the threshold level, and then it will allow that to produce the charger is okay or not. That will be symboled as a AC okay. Okay, so we are repairing it with the help of the different diagrams, like BQ 24780 datasheet. Also you can use, also the motherboard which you can recall that it has the same IC. So let me find out, do we have 28 number pin, the VCC, the DC in voltage which we are injecting 20 volt. Now let's find. Here we are going to use 28. 1 2 3 4 5 6 7 28 17. I am injecting here what voltage? 20 volt I am injecting, and I am getting here 17 point something. Why? There might be some resistor. So how can I find out? So let me remove the DC jack from the motherboard. Let me set it on the beep mode, my multimeter. Now beep mode, and let's keep it here and start searching. Yes, this one. So this is the 100 ohm resistor, which means that the near about 10 ohm we will get on this resistor. The value 10 ohm resistor we will get here. I am getting 132 ohm. That means that this resistor is blown up. Okay, it is blown up. Now what you have to check, now let's come back, inject the DC jack and check the input, because this side was beep from this 28 number pin. Now this side, what voltage I am getting? 19 point around 19 volt. Okay, and what voltage you are getting here, the DC jack, on the DC jack, this is the input of the first MOSFET, 19.93, the same amount I think here, 19.93, 19.9. okay, it's all right, but the I is not okay. That is why my first MOSFET is not switching. My first MOSFET is here, and this side I am not getting voltage. Okay, why? Because my gate is not biased. Okay, it is not biasing it. This is the N channel MOSFET. If you search this part number, you will get that this is the N channel, this line PK6B2BA. If you type it on the Google, you will find out that this is the N channel MOSFET. N channel requires high voltage to drive voltage from the drain to source or source to drain. Okay, however, the diode mode is like this way, so it cannot allow on the diode mode. So that is why you are not getting voltage on this side. So as soon as the voltage reach here, around 6 volt above, 26 volt or 25 volt, you will get on the gate. Then your voltage will be switched to this MOSFET, the second MOSFET, to the source of this MOSFET, and then voltage will go across this MOSFET and it will reach to the sensing resistor, and this is the point. And the guy who has sent this motherboard to me, he checked something and he might be injected voltage here. You should avoid to do work like this in latest generation motherboard. If the high amount of current passed in the CPU, the CPU may be damaged. So what is the problem here? The charging IC is not functioning very well. The second point we have to check here, that is the AC direct, pin number 6. Come here, pin number 6. Are we getting AC direct? 1 2 3 4 5 6. It must be above 2.4 volt. So, okay, as per calculation. Inside there are the op-amp. Dildar sir is very much expert to describe the charging IC. So if you are interested in our course, you can contact on the number and you can get the video course from us. So everything is described there. Now it is all right, AC direct is all right. Now region, that is the LDO. LDO is required here. The region is on the 24 number pin. Here 6 volt we will get. 24, 21, 22, 23, 24. Region is also not up to the mark. It must be I think 6 volt. It must be 6 volt. It should not be less. But who knows that the IC is okay. Might be the input is less current. So the resistor value is it is not up to the mark. Okay, the resistor value is not up to the mark. It is 185/86 ohm instead of 10 ohm. So let's remove it. Look, every case are not same. As I am describing you that the dead motherboard, how to repair the dead motherboard. So the dead reason could be in the absence of 19 volt, in the absence of 3.3 and 5 volt LDO, or 3 volt and 5 volt S5 rail has problem, or sometime RTC is failure, IO requirement is failure, your IO is not triggering, instead of it is having all types of requirements. Sometime the IO is triggering but it is not or the PCH is unable to trigger. So there are so many variety of the dead cases. So all the dead cases are because every time I get call from the across the world that I have seen your case study, I have the same motherboard. It is not necessary that your case would be similar to my case. Okay, you have to keep knowledge, the thoroughly knowledge you have to required to repair the motherboard, like how 3.3 and 5 volt IC work, how charging IC work, how 3 point controller IC work, what is the communication, basic communication requirements, how RTC area works. Okay, how to edit BIOS. There are the very depth knowledge are required nowadays in the BIOS. So let me find out 100 ohm, little bit small, but I will fix it anyhow. And one more thing, whenever you are going to change the resistor before powering up, you must check one thing, that the output area should not be short. However, there is no shorting because very quickly I am making this video. I am not trying to time pass, because I could show you that there is a shorting. Let's check shorting. There are no shorting because first of all, whenever you some of the point you get that the resistor are short, you must check this value, that this area is okay or not. It should not be short. If this is short, it means when you will replace the resistor again it will blown up. Why? Because this area is shorted from the IC area. So most of the time you will get this type of case also. Now the value, let me check, 10 ohm. Okay, all right. Now let me inject DC jack. So here now I started getting 19 volt instead of 17 volt. What is the condition of my region? 5.4 volt. It is still not up to the mark. Okay, that is why it cannot release AC drive voltage. AC drive voltage is around 6 volt above to your VCC. Okay, the AC drive voltage is 6 volt above to your VCC. So I am required charging IC. Now let me BQ. What is this? Yes, good, I have. Now let me replace it. Why I am replacing it? You know the reason? Because there is no LDO up to the mark, the region voltage. If there is a region voltage, I am getting it, if you can say the 5 point something volt, that is not good. Okay, now I have fulfilled its requirement, that the voltage as it was required. And in order to achieve your LDO or region voltage on the charging IC, merely AC detect is required 0.6 volt, above 0.6 volt, and DC in voltage must be above UVLO mod. Okay, UVLO mod means under voltage lockout mode, that is the around 2 that is around 4.75 millivolt, sorry, not 4.5, around 4 volt, around 4 volt. DC in voltage must be above 4 volt, and AC direct voltage must be above 0.6. You will get your region 6 volt in any charging IC, usually. Not any, I am not right. New IC has the new features, okay, and like 30 pin IC and 32 pin IC used to come with the 5.3 volt LDO. That was true. Now I have to use the iron, because I have received battery also. That is a good, that I will check the battery is getting charged or not, if it is okay. It is done. Now let me check the region voltage. Okay, all right. Yes, pin number 1, always match, reconfirm it. The pin number 1 is on the marking side. Good. Now you keep your multimeter on the 24. Okay, now 6 volt. Got it? Now it is 6 volt. That is why I changed this charging IC. Now let me check, do I get this AC drive? Yes, I started getting AC drive on the pin number 4 of the first MOSFET. So of course I will be getting voltage this area. Okay, and sensing register, here I started getting voltage. So it means that my DC in voltage is proper. Now come and check the pin number 1 of 3.3 and 5 volt regulator. When is all right. Now let me turn on. It should be turned on by itself. Why it is not turning on? Still there is a problem. He might have done something else, like BIOS. Why? The pin is broken. See what he has done. So the charging IC was not allowing, it was not allowing 19 volt to pass. Now let me use the different ID. What does it mean? That the BIOS might be faulty. Why? Because I think I will be getting 3.3 and 5 volt. Let me check it. Yes, 3.3 volt on the coil is available, 5 volt on the coil is also available, and 1.8 volt is here. Okay, so you always keep reference first time when you repair the motherboard. This is the 1.8 volt and this is the 1 volt, I think, not this one, this one. So 1 volt is not available. Where it has gone? Now let me check its value. 12 ohm, good. 10 ohm, good. So 1 volt is missing. It must be available. What does it mean? BIOS IC. No 1 volt. So 1 volt regulator is here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5. Unable. No enable. Oh, you are not able to see here. 1, 2, 3, 4, 5. Enable is not present. So I think that I have to do the BIOS. However, I have seen that even the BIOS, whenever not working, on that time the ground, let me check the ground, it's present or not. Yes, it is present. Let's wait few moments. I just come back. So I think the CPU is faulty. How I can say, because if you get G3 model, what you will get, 19 volt is okay, 3.3 and 5 volt is okay if you get this type of problem, and 1.8 you have to check. After 1.8 volt, this is called the prime voltage. The prime voltage in after 6th generation, from the 6th generation onwards, 1.8 volt and 1 volt prime is on the S5 state mode. S5 state mode means that is the standby voltage. So here 1.8 volt is available. Okay, 1.8 volt is available here. Now DSO, let me fix it here. Keep an eye. .8 volt on the output side. Good. Little bit variation, but it is negligible. Now we need to get voltage here. 1 volt. What is the number? L60800. This one. Here I need to get voltage. Now you will see a symptom here. I am turning off my power supply. Now I will turn on. You will see 1 volt is available. Now goes off again on the output side. Let me keep it here. Turn on. Now you see 1 volt is available here and off. Why it is happening? Because most of the time the G3 model, let me turn on this one. Might be he has received it with the charging problem, but he has done something. That is why I am telling you, you should not inject voltage on this from the sensing register in any motherboard. So let's have a look. I have 3 motherboard of the same amount. Okay, this is the 1, 2, this is the 3. From the different persons, from the different states, I have received the 3 motherboard. Among them, I was trying to repair this one. You have seen that the charging IC was having problem with the region area. Instead of 6 volt, there was merely 5.6 or 5.5 volt there was. So that is the charging IC problem, and I replaced it and everything was working fine. 3.3 volt available, 5 volt available, 1.8, but 1 volt is coming and going back. Now you need to have information about the impedance. What should be the impedance of that 1 volt prime area? So prime area in every 6th, 7th, 8th generation, at least 6th, 7th and 8th generation, I am very much sure about this. I have never seen good condition is less than 20 ohm. Okay, usually you will find in like Dell Vegas motherboard, you will find 36 ohm, and in many motherboards around 30 ohm above you will find. Less than 50 ohm and more than 30 ohm. So let's suppose if the worst condition, if I get 20 ohm, that could be either it is all right or it could be bad. So here what I am getting, 12 ohm. Can you imagine that's good or bad? That is why my voltage is not stable. Everything is all right. The enable is coming and going back. The good condition motherboard, in this motherboard, what is the scenario? However, I have seen here that somebody has removed the controller. I don't know why. Might be shorting. The shorting could be reason. And here no worth, 0 ohm. So CPU is short. VCCSA, it is also 0, it's also short. This could be 10 ohm. This must be 10 ohm. And what is here? I'm giving you the reference. This is good, healthy. VCCSA is healthy, but 1 volt prime must be 30 ohm or at least more than 20 ohm. So in this motherboard, the CPU is short. So no concern with this motherboard. Let's throw it unless the CPU replacement offer comes. And in this motherboard, what is the value? 36. This is what I was telling you, above 36 ohm. Now let me inject power, and the CMOS cell is there, it will not turn on. Before turning on, these voltages must be ready. Okay, it should not like that it is happening in my motherboard, turning on and off. The voltage is coming and going back. So 3.3 volt, let me power up. 3.3 volt, it is off, no power. 5 volt available, 1.8 available, 1 volt. So it means that if you get 3 volt and 5 volt, of course you will get 1.8 and 1 volt in the S5 state. So in my motherboard, which I was trying to repair, he has shorted the motherboard. It was not short, I think so. So I will see that what is the problem in this type of motherboard. But the scenario is completed, that as you have seen that how to repair a dead motherboard, you might have understood. That was my concept, that how can you repair those motherboard which has no schematic available. So this is final, that there is no use to change the IC of 1 volt. The processor value, the PCH value is decreased to the shorting level. So inshallah we will make English video, as it is highly demanded, because guys who has told me that don't make videos in Hindi, because the worldwide will see your video. But in fact, what is the problem? That I have the both pressure, that I have to make balance between the both languages. And inshallah I will increase the amount of your videos, and you just keep on commenting on the YouTube box, and keep on sharing. And if you have any queries and concern, you can contact on the given number, and also you can write on the YouTube comment box. So keep on loving us. Thank you guys, thank you for watching this video.